Welcome, Honors Geometry, here to our second video of our first unit here in geometry, and it's great to finally be in our geometry content. Okay, remember, our time here before geometry was spent focusing and looking at algebra topics that were missed last year. Okay, now, nice thing about it, we're bringing back those topics into this lesson. Okay, remember we started with polynomials and talking about combining them and so forth. We're going to see that here today. So our first lesson was on points, lines. We talked about different types of line segments, and rays. Well, today our focus is going to be on just those types of line segments and looking at further properties within them. So our lesson actually starts here with just a refresher, a reminder. So what are segments? Well, first off, segments is just an abbreviation for a line segment. So what are segments, or what is a line segment? These were lines with endpoints on both sides. Now, with segments, we specifically talked about on these segments or line segments, they have a start and an end. Okay, and these are denoted by those endpoints, or what I'm going to just say as points by itself. So if I go down here to the example and draw a visual of that to begin with. Okay, we have two dots or 2 points, A and B. If we connect them and don't go any further, that is a line segment. Okay, remember, there were other types of lines that we talked about. If I go here off to the side and really draw them briefly. Okay, remember we had where we had arrows on both sides. This is a line. These arrows represent they go on forever. So a line has no stopping, no end point. Okay, no beginning, no end. So it's continually being drawn. Okay, and the other type of special line that we talked about was a ray. Okay, which remember, a ray is like a marriage of a segment and a line. Okay, it has a beginning. Okay, but it has no endpoint. It goes on forever because it has the arrows. Okay, this is going to come back to be important here when we talk about this next piece of information. Okay, so now, how do you name a segment? Remember, we name them with the 2 points with the symbol of a line segment above. Okay, now there was 2 ways, remember we talked about this, that sometimes people draw them. Sometimes people will draw them just with A, B with a line and no points above. That is acceptable. That is a way to denote a line segment. You will see that here in a lot of problems later on. Okay, we could also see it as A, B with that line and the 2 dots above it. Okay, whether or not you want to include the dots or not, that is up to you. Both ways are acceptable ways to denote a line segment. Now, again, remember, it doesn't matter the order that you name the points. I could have also named this BA. Okay, you don't have to name them in certain orders for a line segment. Rays matter, lines and line segments do not matter the order of your points. Okay, getting down here to the second thing. Do segments have length? Okay, well, before we get any further, let's talk about what is length. Okay, well, length. Length is another word for distance, for measure. Okay, it specifically talks about how long something is. Okay, when I think about length or distance or measure how long something is, I think about bringing out a ruler and measuring something. Okay, that is what we're doing here when we talk about these lengths of segments. So do segments have length? The answer is yes. Okay, and what we're basically going to be doing, it's like we're pulling out our ruler and we're going to put it up against the line segment and read it off. Now, why they have length is because they have a starting and an ending point. These are the only types of lines that have lengths. Lines by itself do not have lengths because I don't know where it stops or where it ends. The length of a line is infinite. It is as big as it continues to go. There is no number in our world that is big enough to say the length of a line. Same thing with array. It has a starting point, but array extends on forever. Because they don't have a start and an end, we cannot find the length of these. We can only find the length of segments. So how do you note the length of a segment? There are going to be multiple ways. You can denote it with saying the distance of and then filling in the segment. You can denote it by saying the length of something and put the segment there. We can simply denote it with a little m, which this is the little m that talks about measure. So I could have the little m and put the symbol right of the segment beside it, or you can just have the segment by itself. Anytime that you look and say, like, find AB, and it's just like this, find AB, that's another way of saying finding the length or the distance. So, an example, and I'll write out all 4 of those ways of how you would see it. Okay, we'll say AB, and it has a length of 7 inches. So, you could have, what is the distance of AB? There is the denotion of how you would see distance. Okay, we could have, what is the length of AB? Notice distance and length have the same wording. Okay, find the little m for measure of AB. And I could also have find AB by itself. All 4 of those questions get the same answer. They're all asking you for the length or how long it is. It's 7 inches. It's told in our picture. Okay, going on here to the next idea with segments, and it is, what are congruent segments? So we run into another word. Let's define it before we get any further. So what are congruent segments? Congruent. Congruent, first off, has a symbol. It is an equal sign with a squiggle or a tilde above. Okay, congruent means it is the same. It is the same length, distance, whatever you want to talk about it. Okay, so in this case, what are congruent segments? Well, these are segments with the same length or distance. Okay, there's 3 ways that we could denote that something, or in this case, that we have congruent segments. Okay, the first way is symbolically, they would put 2 segments, let's say A, B, and C, D, and they just put that congruent symbol in between. Okay, remember this is that same symbol up there. Anytime you see that congruent symbol in between pieces of information, whether they're segments, we'll talk about it here with angles and so forth, it means they are the same exact thing. They're the same length. They're the same everything. Okay, another way we could have this denoted is we could simply have a B and C D and either above or below, they tell you they're the same. Okay, simply they told me they're both 3 inches, therefore they are congruent. They are the same length. Okay, your measure can either be above or below the line. These are below. And then the third way we could see this for congruent segments is I have AB and I have CD and I have these little lines in them. Okay, these little lines are known as tick marks. Okay, tick marks show congruent. So anytime you see pieces of information with the same number of tick marks, everything with the same number of tick marks are congruent. So since these both have 1 tick mark, they are congruent since they have the same number. Okay, when I talk about having the same number, if I would draw here A, B, C, D, E, F, and then I'll do G and H here up at the top. Okay, if I have 1 tick mark on AB and 1 tick mark on EF, those are the 2 that are congruent because they both have 1 tick mark. Then if I would have 2 tick marks, they're basically 2 lines on CD and GH, those 2 pieces are congruent. So CD and GH are congruent because they have the same number of tick marks. Same thing with A, B, and EF. Those are congruent because they have the same number of tick marks. Okay, they are all 4 not congruent to each other because they don't have the same number. Okay, but that's how we deal with the tick mark. Okay, we'll see them here later on to get familiar with them as well. Okay, so now let's see here what is our next vocab. Okay, our next vocab, which is a main thing of what we talked today here, is segment addition. Okay, what is segment addition? Okay, so the segment addition postulate, okay, this is a postulate that allows us to find missing values on a segment. Okay, now, really that means nothing. When we get down here to the example is where it's going to make sense. Okay, and you're going to hear me say the pieces of information when we get down there quite a bit. Okay, when do you use the segment addition postulate? And it all comes down to what it is. We use it when we are missing values on a segment, and particularly we use it when we want to find missing lengths of the whole segment or part of the segment. Okay, so now we get down here to an example. What these segment addition postulate problems are going to look like is you have a segment, you have your 2 endpoints somewhere inside. Now, it doesn't have to be right in the middle, is going to be another point. And what has happened is that other point makes it that we have these different parts of the segment. Okay, now, there's 3 ways that I denote segment addition. They all mean the same thing. It's really what are you comfortable with. Okay, the segment addition comes into this idea of part plus part equals the whole thing. Okay, a part of the whole segment is AC. Another part of the whole segment is CB. The whole segment is AB. So if I have these little parts, if I add them together, they give me the whole thing. Okay, another way I sometimes denote it as piece plus piece equals the whole. These parts are also known as pieces. If I take a piece plus a piece, it gives me the whole thing. Okay, and then a third and final way that we can denote this is little plus little equals big. Okay, these parts are the little pieces of it. This big is the whole thing. Okay, whichever way that you remember segment addition, okay, is fine. Now, if I think about this visually, okay, I have this glue stick. This is my whole thing. Okay, I have broken the glue stick up into two pieces. Right here is like, there is my thing. This where they break up is point C. If I am to put these together, they give me my whole glue stick. So they do. Okay, I have a part and a part. Okay, a part and a part. If I put them together, they give me the whole glue stick. Okay, that is like your segment addition. You have you have a whole thing, they have separated them. But if you add them or put them back together, they are going to give you your whole thing back. Okay, and now, if we start to look at these problems, the first thing I'm going to tell you about segment addition is if you have multiple problems dealing with the same picture, redraw your picture. This first problem, I have 1, 2, 3, 4 parts that deal with the same picture. For each part, I'm going to redraw that picture. Drawing this unit and here on out in geometry is important. Geometry is a lot of visuals, okay? If you don't visually have a picture, you're going to end up drawing it. Okay, so get used to the drawing parts. Okay, now, the next big thing in geometry is to take the given information and put it on your picture. So if I look here at 1A, okay, one piece of given information, and I'm going to highlight it, is they tell me PQ is 34 centimeters. I'm going to go over here, PQ. Okay, I've highlighted PQ. All that I'm highlighting is what is between P and Q. They tell me that's 34 centimeters. So it's 34 centimeters. I mark that. Another piece of information that they give me is QR is 23 centimeters. Q to R is 23 centimeters. Okay, they want me to find PR. They want me to find the length of PR. Okay, well, if I think about this, okay, I know P to R, which I'm going to do is from P to R is there. This is what they want me to find, and I'm going to write the word find. If I think back up here, piece plus piece equals the whole thing. Your whole thing will always have this bracket. Little plus little equals big. Part plus part equals whole. Piece plus piece equals whole. Either way works. So if I think about this, 34 centimeters plus the 23 centimeters is going to equal my PR, or what I want to find. Okay, I can combine these. 34 and 23 give me an answer of 57 centimeters equals PR. Right there's my final answer. The length of PR, or the distance of PR, is 57 centimeters. Okay, going here to the next problem. If PR, I see a piece of given information. So they tell me PR is 96 centimeters. PR, first off, that is the whole big thing, so I'm going to put it as a bracket. How I know it's the whole big thing is it goes from one end to the other end point. So I'm going to put 96 centimeters below it. They tell me PQ is 37, which again, notice I went through, I highlighted it, so I visually see these pieces of information. They want me to find QR. So they want me to find QR. I highlight it. That's what I need to find. Okay, I'm going to remember piece plus piece equal whole. Little plus little equal big. Notice my blue and my yellow lines were a lot smaller than this orange line. So little plus little equals big. So little 37 plus little, the other little is that QR, equals the big, which is 96. Okay, I don't always need to include the centimeters, the inches, the unit of measure. I can do it just simply with the numbers. Getting QR by itself. Subtract 37 on both sides. This gives me QR equals 96 minus 37 is 59. And then I'll put the units after it. QR is 59 centimeters. Okay, let's go here to C. They tell me that PQ is 2x. So I find PQ, and I'm going to also mark that as 2x. Marking your picture is important. They tell me that QR is 4x plus 5. So QR is 4x plus 5. They want me to find the length of PR. Okay, so if I think about this, PR to R is the whole thing. It goes from side to side. This is what we want to find. Okay, if I look at the lengths of my colored lines, pink is my biggest. That represents my whole. The orange and the blue are the smallest. These are my little, my pieces, or my parts. So, part of 2x plus the other part of 4x plus 5 equals the whole thing, which is PR. Okay, to find the length of PR, combine like terms. 2x and 4x can become a 6x plus 5 equals PR. There's nothing more I can combine. That becomes my final answer. So this brings us back into when we talked about how do we add polynomials back in that first unit in our geometry or in our algebra material. Okay, so now let's go here to the last problem with this same visual. They tell me PR is 9x plus 2. P to R, which is that whole big thing, is 9x plus 2. Okay, they go on to tell me PQ is 2x plus 6. PQ, 2x plus 6. They want me to find the length of QR. So I'm going to highlight QR. This is what they want me to find. Okay, I'm finding a part of a segment. Remember, segment addition is used to find either a part or the whole thing. So part plus part equals whole. One of my parts is 2x plus 6. The other part plus the other part of QR equals the whole thing of 9x plus 2. Okay, I need to get QR by itself. So I'm going to subtract 2x on both sides. This gives me 6 plus QR equals 9x minus 2x is 7x plus 2. Subtract 6 on both sides. I get QR equals 7x minus 4 because 2 minus 6 is a negative 4, so it'd be a minus 4. There is my QR. All that I'm doing is I'm going on every one of these problems and I'm substituting back into either one of these. Okay, they all mean the same thing. Okay, looking here at the last one. Okay, I'm going to use the diagram on the right to find the following. So in this problem, they tell me EG is 71 inches. Okay, from E to G. Notice that goes from one end to the other, so it's the whole thing. That's why I put the brackets. That's 71 inches. They want me to find X and the value of EF. Anytime you see that they want you to find more than like a variable on these problems that have algebraic expressions, we're going to have a substitution part at the end. So the first thing I'm going to solve for is X. Here is my parts. My parts are EF, which is 8x minus 17. And the other part is FG, which is 5x minus 3. So 8x minus 17 plus the other part of 5x minus 3 equals 71. Okay, this is still going back to that first lesson. We're combining like terms to solve for x. We're going back to our linear expressions, even which we talked about at the end with factoring. Okay, 8x and 5x becomes a 13x. Negative 17 and a negative 3 becomes a negative 20 equals 71. Unless you're crossing the equal sign, remember, you're not changing the signs. That's why the 8 and the 5 both stayed positive and the 17 and the 3 both stayed negative. You only change the sign when you cross the equal sign. Now, I have to cross the equal sign, so I need to add 20 to both sides. 13x equals. Okay, I have a 91. Then I would take everything divided by 13. Okay, 91 divided by 13 gives me an answer of x equals 7. Okay, that is the one thing that we needed to find. Okay, we had to find two things, x and EF. Once we found x, to find EF, I have to substitute in. EF is going to equal 8 times 7 minus 17. I'm substituting in. 8 times 7 is 56 minus 17, and I get an answer of 39. So EF is 39, and now I could include inches if I wanted to. Okay, this is what we're looking at here today. Part plus part equals whole. Little plus little equals big. Okay, let's continue to look at more of these examples. So, looking here at this one. First thing they tell me that is not on my picture is TV equals 14x minus 8. TV is from beginning to end, so that's a whole segment. That's why I'm putting the bracket. 14x minus 8. They want me to find x, tu, and tv. Okay, we're going to start with x. Just like we saw on the last one, our pieces or our parts are already labeled. Tu is 9x plus 2. Uv is 5. So, part plus part equals whole. One of my parts is at tu, which is 9x plus 2. Other part is uv, which is 5, equals the whole thing, which is 14x minus 8. Okay, combine like terms on my left-hand side. 9x doesn't go with anything, but 2 and 5 becomes 7. This is 9x plus 7 equals 14x minus 8. Okay, I'm going to get the x's on one side, so I'm going to subtract 9x to give me 7 equals 5x minus 8. Add 8 to both sides. I'm going to go up here on the right-hand side. When I add 8, I get 15 to equal 5x. Divide by 5. I get x to equal 3. Okay, there is my x. Once I have x, now I'm going to go through and substitute in. I need to find TU. TU. This would be 9 times 3 plus 2. That'd be 27 plus 2. I get an answer of 29. Okay, TV was this 14x minus 8. To find it, 14 times 3 minus 8. 14 times 3 is 42 minus 8. And I get an answer of 34. So TV is 34, TU is 29, and x equals 3. Okay, one more problem under this segment addition. Some of it again is marked, some of it is not. CE is 7x plus 4. C to E, which is from endpoint to endpoint, or the whole thing, is 7x plus 4. Okay, notice CD is marked, it's x plus 3. DE is marked, it's 8x minus 9. Part plus part equals whole. X plus 3 is a part plus 8x minus 9 is a part equals the whole thing, 7x plus 4. Part plus part equals whole. 8x and an x become a 9x. 3 and a negative 9 become a negative 6 equals 7x plus 4. Okay, to get the x's by itself, I always move the smallest x, so I'm going to move that 7x to the other side, so I subtract it to give me 2x minus 6 equals 4. I'm going to then add 6 to both sides. I give 2x equal 10. Divide by 2, I get x to equal 5. Now, they want me to not only solve for x, but to solve for every piece. CD, DE, and from C to E, which is the whole thing. So, if I start with CD, CD is x plus 3, so that'd be 5 plus 3, which is 8. Then if I go to DE, DE is 8x minus 9. So that'd be 8 times 5 minus 9. 8 times 5 is 40 minus 9, which is 31. And then CE, which is this whole thing of 7x plus 4. That'd be 7 times 5 plus 4. That's 35 plus 4, which is 39. Okay, and there would be all of my answers. Okay, let's go here and look at this last piece, midpoint. Okay, midpoint. This is something that we're also going to see here later on. This is just a preview, but it's going to help us also with some segment addition problems. Okay, so first off, on these midpoints. Okay, this midpoint is a point that is directly in the middle of a segment. Okay, the main thing it does is it cuts a segment into 2 equal pieces. Okay, so how we would see a midpoint is you're going to have a segment, okay, which in this case we'll say is AB. There's going to be a point somewhere in the middle, which we'll say is C. Okay, now if this is my midpoint, there's 2 ways that I know, or 3 ways I know it's the midpoint. Sometimes they will tell me it's the midpoint. The other way is if you have tick marks on either side of a point, that is telling you that that's a midpoint. A midpoint cuts something into 2 equal pieces. When we get to work with these problems, you should always be putting tick marks on either side of something that is a midpoint to show that that point cuts it into two equal pieces. Okay, the other way that we could do it is if you know one side is 5 inches, on the other side of the segment it's also the same thing. So a midpoint has the same distance or length on either side of it. Okay, and now we get down here into this next one. What is a segment bisector? This is either a segment, which remember is another word for line segment, or a line that crosses over the midpoint. Okay, so visually what this is going to be is you have a line segment, let's say AB, you have a midpoint which is C, and I'm going to abbreviate that that's a midpoint with MP. You're going to have either a line or a line segment that goes through and is drawn right through that midpoint. That's what a segment bisector is. Okay, let's go back here to these last 3 problems which use some of our ideas from midpoint in it. So looking here at this diagram on the right, okay, they first tell me a big piece of information. Q is the midpoint of PR. So Q is my midpoint. I'm going to put MP. First thing we should be doing when we see something as the midpoint is you need to put tick marks on either side of the midpoint to show that those pieces are congruent or the same. Okay, here in this first problem is they want me to find the value of X. If pieces of information are the same, they are congruent. Congruent or same pieces of information are set equal. So since I know P, Q, and QR both have a tick mark, they are congruent. To solve for X, I just set those congruent or equal pieces equal to one another. So 7x minus 16 equals 4x plus 2. I'm going to subtract 4x on both sides to give me 3x minus 16 equals 2. Add 16 to both sides. I get 3x equals 18. Divide by 3, I get x to equal 6. Okay, I'm done. That's all they wanted me to do was to find x. Okay, so now let's go down here to B. Okay, here on B, H is the midpoint of GI. H is my midpoint. I'm going to put an MP so I know it's the midpoint. On either side of midpoint, I need to put tick marks so I know that those pieces are congruent. If I have pieces that are congruent, I set them equal. So 9x minus 10 equals 5x plus 2 because they both have a tick mark. They are congruent. They are the same length. Solving for x, I'm going to subtract 5x to give me 4x minus 10 equals 2. I'm going to add 10 to both sides. I get 4x equal 12. Divide by 4, I get x to equal 3. Okay, that's part of what they want me to find. They wanted me to find x. They also want me to find GH and HI. So I need to substitute in. GH, that'd be 5 times 3 plus 2. That's 15 plus 2, that's 17. And then HI, that would be 9 times 3 minus 10. That's 9 times 3 is 27, minus 10 is 17. Notice, GH and HI both give me 17. They better both give me 17. Since they both have a tick mark, remember, tick marks mean they have the same length, they have the same distance. So they both better be 17 for the length or the distance. Okay, then here, C is the hardest problem on this whole lesson. I'm challenging you a little bit because they have both an X and a Y. Okay, so I'm going to give you a second. See what you think you get for X and Y. Then I'm going to go through it with you and we'll talk about this one. Okay, so now that you've had time to try this, let's talk about it. First off, they tell me G is the midpoint of FH. Okay, G is the midpoint of FH. Below G, I'm going to put MP for midpoint. I'm going to put tick marks on both sides. I'm ignoring the rest of the problem. From A and B, I can solve for X automatically because if I have a midpoint, I put tick marks on either side of the midpoint to show that those pieces are congruent. If pieces are congruent, I set them equal to one another to solve. So I'm setting those pieces that have tick marks that are congruent equal to one another. Solving for X, I'm going to subtract 4X on both sides. 3X minus 12 equals 3. Add 12 to both sides. 3X equals 15. Divide by 3, I get X to equal 5. Okay, I found the value of X. There's one thing that they wanted me to find. I can now also find FG and GH because I can substitute in my X. I know FG would be 4 times 5 plus 3. I get an answer 23. Okay, I also can find GH. 7 times 5 minus 12. 7 times 5 is 35 minus 12 is 23 again. FGGH. I found that. Now, they also want me to find FH. Part plus part equals whole. FG is a part. GH is a part. My whole thing is this FH. So if I remember part plus part equals whole, part plus part equals whole whether or not you have a midpoint or not. Okay, one of my parts is 23 plus my other part is 23. It equals the whole thing, which is FH. 46 equals FH because when I add 23 plus 23. Found FH. What I'm left with is Y. Okay, there's another piece of given information they tell me. They also tell me that FH is 6Y minus 2. I ignored that here for a while. FH is also 6Y minus 2. What we're going to learn here at geometry is when you have something that is equal to two pieces of information, you can set those two pieces of information equal to one another and solve. I know FH is 46, but I also know FH is 6Y minus 2. Since FH is set equal to two things, I set 6Y minus 2 equal to 46 and then solve for Y. Add 2 to both sides. This gives me 6Y equals 48. Okay, I would then go through and divide both sides by 6, and I get that Y equals 8. Okay, you will learn here in geometry, we see it quite a bit. If something is two pieces of information or at one thing, you can set those informations equal to one another. Okay, that finishes up here our segment edition. If you have any questions right now, put it in the video. Ask them. We will go through this. Remember, in class, we're still going to go through examples like this. Okay, some pieces of interaction for you to be able to give me feedback on what you know, what you don't know. Okay, so otherwise, I hope you're having a great day, great night. Whenever you're watching this, I hope you're doing well. If there is anything that I can do for you, please reach out. I'm here to guide you to have a successful year. Okay, I'm enjoying teaching you, and I will see you in class. Have a great day.